Welcome to video lecture number 2, Signs of Chemical Change. During a chemical reaction, there are telltale signs or pieces of evidence that a new substance with new properties is being produced. You need to be able to recognize these signs of a chemical change, and you've probably already experienced most of them in your lab investigations. Please stop the video and write down the essential question in your notes. A molecule is two or more atoms that have chemically bonded together. In a chemical reaction, molecules can change into different molecules through the rearrangement of their atoms, through the making and breaking of chemical bonds. More specifically, atoms of the reactants or original substances rearrange to form new molecules called the products of the reaction. A chemical equation can be written to show what happens to the atoms in the chemical reaction. Chemical equations are written like this: the reactants yield the products. If you have ever seen water, you've seen the result of a chemical reaction. In this combustion reaction, oxygen gas, O2, and hydrogen gas, H2, rearrange to form water, H2O, in a pretty spectacular way, like the Hindenburg up here. The balanced chemical equation for this reaction is written like this. In this reaction, the reactants, hydrogen and oxygen, have different properties than the product. Oxygen gas and hydrogen gas have different properties than water. In gas form, water vapor may look similar to both hydrogen gas and oxygen. They are all colorless gases, yet they have different chemical properties. Oxygen and hydrogen are flammable. Water vapor is not. Hydrogen gas is much lighter than both oxygen and water vapor. The molecular structure of water is different from the structure of both oxygen and hydrogen gas. These properties can distinguish the reactants from the new product of the reaction. These differences allow scientists to identify when a chemical reaction occurs. Let's talk about evidence that the rearrangement of these atoms and the formation of new molecules is actually taking place. The production of a gas may be a very sure sign, if not the most sure sign, that a chemical reaction is taking place. One very common reaction that involves the production of a gas is mixing sodium bicarbonate, also known as baking soda, with an acid such as vinegar or acetic acid. The products of this reaction are water, carbon dioxide gas, and a substance, a solid, called sodium acetate. During this reaction, you can see bubbles in the solution. These bubbles are caused by carbon dioxide gas escaping into the air as the reaction takes place. The chemical equation for this reaction is down here. Vinegar plus baking soda yields the new products or new molecules of sodium acetate, water, and carbon dioxide. Now, don't mistake boiling as a chemical reaction. It's not the production of a gas. So boiling is not a chemical reaction. It's the result of heating a substance so that it evaporates. Another good sign that substances are rearranging atoms in a chemical reaction is a change in temperature. Chemical reactions can either give off heat, in which case they are exothermic, or they can use heat and feel cold, or are endothermic. Perhaps you've had an injury and you've applied a chemical heat pack to that area. A chemical heat pack is an example of a reaction that produces heat, or is exothermic. A common substance in heat packs is one you've used in the lab, magnesium sulfate. When the heat pack is activated, the magnesium sulfate reacts with water. This results in the production of heat, which you use to soothe your injury as that new substance is formed. Chemical cold packs work in the opposite way, to use heat as they build chemical bonds and form a new substance when they mix with water. They feel very cool to the touch. These temperature changes are good evidence that a chemical reaction has taken place if they are not caused by an outside source. For example, if you heat water on a stove, or if you put water in the fridge, the water will change temperature, but not because a new substance is being formed, not because chemical bonds are being broken and formed, but because you are adding heat yourself or taking heat out of the water yourself. A third sign that new substances are being formed during a chemical reaction is the production of light. The burning of logs in a fireplace is the reaction of the wood and the oxygen, along with a heat initiation source. You have to put in a little energy to start that reaction. Wood is made of cellulose, a combination of different substances that contain carbon, hydrogen, and oxygen. When this reaction occurs, a large amount of energy is produced. It is very exothermic. This energy is in the form of both heat, but also in light. This type of reaction is a combustion reaction. It is similar to the reaction that produces the bright light and heat in fireworks. Bioluminescence is a really cool example of a chemical reaction. It's light that living organisms emit because of chemical reactions. Think of fireflies. Even some algae, like these ones on the beach, and fungi are bioluminescent. One sign of a chemical reaction that we demonstrated in the lab is the formation of a precipitate. A precipitate is a solid substance that forms and separates from a solution. A precipitate often settles to the bottom of a liquid reaction. One common chemical reaction that forms a precipitate is the reaction of solutions of lead nitrate, PbNO3, and potassium iodide, Ki. Each of these substances in a solution is clear and colorless. They have certain properties. But if you mix a solution of each substance, lead iodide and potassium nitrate, forms as products. Lead iodide is insoluble, so it separates from the solution as a yellow precipitate, shown right here on the image to the right. The potassium nitrate remains in the solution. The chemical equation for this reaction is right here. In the last example, lead iodide, that precipitate, was a yellow color. That's an example of our fifth sign of a chemical change, a change in color. Usually that change in color needs to be unexpected. You mix two clear solutions, you don't expect them to turn yellow. Now, you may have seen rust form on steel objects before, such as a chain, or an automobile, or nails. In this chemical reaction, iron, Fe, in the steel reacts with oxygen, O2, in the air, as well as water vapor, H2O, to produce the new substance rust, FeOH3. The properties of steel are different than the properties of rust. Steel is a shiny silver metal made from iron and other elements. Rust is a flaky reddish-colored substance. The change in color from silver to red provides evidence that a chemical reaction has happened. Rusting is a complex reaction that happens in certain stages. Overall, though, the reaction could be written like this to represent the rearrangement of atoms from the reactants to the products. The last sign that a chemical reaction is occurring and a new substance is forming is a change in odor or smell. Have you ever driven by a dead animal on the highway? The smell is horrible, and it's caused by a chemical reaction that occurs as the animal decomposes. An unexpected change in odor or smell can indicate that a chemical change has taken place. My son has the bad habit of taking an apple out of the fridge without asking permission. He does this because he knows that if he asks for an apple, his mother or I will only give him half an apple. We only give him half because he never finishes a whole apple. He gets full before the apple is eaten all the way. But he wants a whole one, so he takes a whole one. When he's eaten half and is really full, he knows he'll get in trouble if he puts it back in the fridge. So invariably, he tosses it behind the couch, a hiding place that he believes is sure to work every time. You've probably seen fruit chemically react with oxygen in the atmosphere. What happens when you leave half an apple out? It turns brown, a color change, and if you leave it out long enough, it begins to smell funny too, because it ferments. Both the color change and the odor change are signs that a chemical reaction is taking place. Thanks for watching.